Good evening, guys. Hope you people are doing very well. So today I am just present here to discuss about the NumPy operations. So basically we have to know why NumPy and why it is important today. Why NumPy? But what is NumPy? To know that one, so we can read this line. NumPy stands for numeric Python, which is a Python package for the computation and processing of the multidimensional and single dimensional array elements. Reshaping a number array, indexing and slicing a NumPy array, replacing the element in NumPy array, manipulating NumPy array, performing mathematical and statistical function using NumPy. So basically NumPy is a package through which we can do the different kind of the functions very quickly. If we are not writing any Python program, but through NumPy we can do multiple mathematical operations, we can change the number, we can indexing and slicing through NumPy. So this is very much important in the field of the data science. Basically in the data science field, the people are getting the raw data. So if they are getting the raw data, so from that data, if we want to filter that one, so in that case NumPy is really helpful to do the process very faster, to take the initial or important output, the features from the raw data set. So that's why we need to learn the NumPy. So this topic, the receiving number, indexing, slicing, NumPy array, replacing the element, how we can do these things, we can get to know when I am just run the program one by one. So when you are run this program in your Anaconda or the VS Code, so you have to do the pip install NumPy. What is the meaning of this command? Through writing this command pip install NumPy, then through this command we can just install it in that environment, Python environment, the NumPy. Then I just run another command, the pip install upgrade pip. So this command basically just upgrade the pip. Then to start or run a NumPy program, so we just import the NumPy. So that's why I just write down import NumPy as np. So by writing this line, we just import the NumPy first. Then we can know how to create a one-day array by using NumPy. How we can do that? We just take the variable arr is equal to np.array, and within an array I am using 1, 2, 3, 4, 5, and I just print the arr. If you just print arr, that in that case, and 1, 2, 3, 4, 5, this array basically print here by running this program. Then after that we just get to know about the creating a 2D array. Then one day is already completed, then we can discuss about the how to create the 2D array. To create a 2D array, I am using the arr underscore 2D, this is the variable name, is equal to np.array. What is the np? I already write down here import NumPy as np. So basically np is the short name of the NumPy. So in every time we do not use the NumPy, we just use the np. So Python can easily understand np is basically the NumPy. So in here, if you see arr underscore 2d is equal to np.array, then I am using the first bracket yellow color, then I am using third bracket in the purple color, then I am using the third bracket in the blue color. So I am using basically two third bracket here. So within the blue third bracket I am using 1, 2, 3, then comma, I am separate it 4, 5, 6. Then I just printed arr underscore 2d. So by running this program, we can easily understand 1, 2, 3 is the 2D array. It is the one part 1, 2, 3 and 4, 5, 6. How we can identify? We can see in here there is two third bracket closing. So by seeing this also we can easily understand this is the 2D array. If you observe in the 1D array, in 1D array, one third bracket is used here. Then I just want to transfer it in the list format. So, or I want to check which format it is basically. So I am using the my underscore list is equal to 1, 2, 3, 4, 5. Then I just check the type. Basically type function gives which kind of data type it is. This is basically the list. So that's why they are giving the list output. Then again I am using the arr is equal to np.array. Then I am using the function my underscore list Which one is the my underscore list is this variable. I'm just passing this variable within np.array function. So if I am just passing this my array list, this one, then if I just print it this error, then again I am getting the output of this 1 2 3 4 5, this array. This array I am getting this way. Then I just print the error, then again I am just getting the 1 2 3 4 5, this same array. Then if I want to check the type, then I just write down the type error, then they are just giving this is the numpy.n dimensional array. Then again I check that error.ndim, then I am getting the 1. This is basically the 1 dimensional array, so that's why they are giving the output 1. Now we can just discuss about the creating arrays with zeros and ones. How we can create the array by using 0 and 1. I am just taking the one variable. The variable name, it can be a, b, c, anything. So I am using the zeros variable is equal to np.zeros. np.zeros basically the function. If I am using that, np.zeros means numpy.zeros, I will use all zeros. Then I am creating one array. I am using the yellow first bracket, then within that the purple first bracket 2 comma 3 comma data type is equal to int. That is basically meaning 2 is the row and 3 is basically the column. So when the NumPy will make the array, so they are using the 2 rows and 3 columns, and data type is equal to int means they are using the int type data set. Then I am just printing the array of zeros, then I just print the zeros format. If I run the program, then I can see here this is the array. How they are using this line, just try to understand guys. They are using all zeros here, and they are using 2 rows. You can see 1 and 2 rows, and they are using 3 is basically the column. 1 2 3, they are using 3 column here. Now they are just changing the zeros here. How they are changing? np.ones. If we are writing down np.ones, then instead of using the zeros, NumPy will use all other 1 here. Rest of the all program is like the same, like the previous program. Only we are changing that np.ones. This function. This function basically np.ones using all are 1. Now array with a range of values. With a range of values means range basically gives one starting point will be there and one ending point will be there. So range means this is the one starting and one ending will be there. How we can use it in NumPy? I am just taking the one variable range underscore array is equal to np.a_range. np.a_range basically one function which give you a range, and within the first bracket I am using the 10. 10 means it is starting from 0 and it will go till 10. Then I am just print the array with a range of values. Whatever you just want to write down, it doesn't matter. I am just using this one. Then I am just printing this variable range array. If just run that program, then we can see this range function is basically gives 0 to 9. First point is basically included. Always the number starts from 0, and the last point that is excluded. The 10 will not be included. So that's why they are giving the 9. If I change that, instead of using 10, I am using the 20. If I run that program, that you can see the program will give the output from 0 to 19. Yeah, see, the program is gives the 0 to 19. Basically, np.array a range function gives a range till whatever I am just passing the number. Then array with a range of values with a step value. What is the step value? Step value is basically jump. How? In the Python program or the NumPy, they are taking the jump. I am just checking it here. I am just using one variable range underscore array is equal to step is equal to np.arrange. A range function, again I am telling you that the starting and ending point will be there. So this 1 is basically the starting point, 20 is basically the ending point, comma this third variable 2. This third variable 2 is basically gives the step value. If I run that program, if I print this variable range underscore array underscore step, if I run that program, you can see the program will start from 1, then they're just taking the 1 missing, 3, then 4 missing, 5, that this 2 is basically the step value. So that's why they are just taking the 1 plus 2 3 plus 2 5 plus 2 7. In this way they will go till the range. If I change the range value, instead of using 2, I am just checking that 1. If I just run the program, we can see first point they are taking the 1, the starting point will be there, then they will be adding 3 here. 1 plus 3 4, 4 plus 3 7, 7 plus 3 10 till 19 it will go there. Then I am just taking one vector underscore row, and I am taking the np dot array, one array I am just taking it here, 1 2 3 4 5. Then I just make the printout vector underscore row, and I am getting this output 1 2 3 4 5, 1 2 3 4 5 here. Then I just take how the output can be slicing. In here you can see we are just printing vector underscore row, and within third bracket I am not using anything the first. That means it starts from 0, then colon 3. So starting point will be the 0 and ending point will be the 3. Basically ending point is always not included here. Starting point always included, ending point is excluded. So in this array they are just starting with 1 2 3 4. How it is the positioning? The first position is 0, second position is 1, this 3 is the 2 position, second position, and 4th is the third position. So third is not included here. The 0th position is the 1, they are taking the input here. First position is the 2 and the second position is 3. So it will go there. And third position it will not be included in here. So that's why they are just taking this 3 position, 0 first and second. So 1 2 3. So they are giving the output 1 2 3 here. Now I am just taking the vector underscore row is equal to np dot array 1 2 3 4 5. I am just taking the same array like previously, and I just print out vector underscore row within third bracket 2. 2 is basically, this is the way to write down the position, which is the position in the array. And the list, we always remember it, always all the number they are kept inside it according to the position. What is the position? This is the first position, that is the 0, 0th position, first position, second position, third position, fourth position. So in here I am just print out the second position. Which one is the second position? 0, first and second. This 3 is the second position. So if I run that program, I am getting the output is 3. In here I am just taking another array 1 2 3, 2-dimension array. How I can identify? You can see that double second bracket is there, and I am using that one. And after that, if I run that program, I am just write down the vector underscore column is equal to np dot array 1 2 3 and vector underscore column dot ndim. Ndim basically gives the dimension of the array. So I already explained that this is the 2-dimension array. That's why they are giving the 2 output here. In here, this is basically the 3-dimension array. How we can identify that one? So if I run the program vector underscore column is equal to np dot array, I'm using the first bracket here, then yellow color, then purple color third bracket, then blue color first bracket, and after that I'm just write down print within first bracket. I'm passing vector underscore column. I just want to print out this one dot size. Dot size means what is the dot size give you the, this function is basically gives you that how, what is the size of there 1 2 3, 3 size is there. That's why they are giving the 3 output. If I am using here one more variable, let's see what will happen. I'm using 4 and I'm running the program. Yeah, 1 2 3 4. The size of the array is the 4, so that's why they are giving the output, that is the 4. Now I am just taking one matrix variable is equal to np dot array. I am using the 4 data type here 1 2 3 4 5 6 5 9 0 9 8 10 and 5 4 3. This 4 1 2 3. Let's count again 1 2 3 4 and 5th. So I am taking that one. I am just printing the matrix. Then I am just getting all the arrays here. Then after that the matrix there, and what we do that I am just slicing. How we can do the slicing, let's see. So basically these two layer line are not giving anything else. I am just taking that one, I am just giving the printout. So that's why they are till this program it's remaining same like the previous program. Then after that I just try to print out separately. How we can do that? Basically I am using print within first bracket, matrix is there, and within third bracket I am using 4 colon 0. Basically this position is taking the row and the second position is basically taking the column. How it takes that one? So this one is the row 0 1 2 3 4, and this one is the column 1 2 3. This is basically 4 by 3, 1 2 3 4 5, 5 by 3 matrix. Then in the first time they are using the fourth means they are taking the row. First variable is basically taking the row. This position is basically taking the row 0 1 2 3 4. This is the basically fourth row we are selecting here. Then comma 1.0, this means it will be starting the this position is basically taking the column. This is basically taking the column. So this is taking the first position. In the column, this is the 0th position, this is the first position, this is the second position. So this is the first positions. Basically earlier I just select this column, this row. Right now I am selecting this column. This is the first column till end. So that's why they are giving the 4 and 3. Firstly they are checking the row 4th comma 0. This is the 4th row till end. Then this is the column. This is the first column till end. Till end means basically if we are not giving anything, that is basically taking the till end. That's why they are giving the output 4 and 3. 4 and 3 output we are getting here. Now again, this is the backward process. What is the backward process? This matrix is equal to, again I am taking np.array. I am taking this array. Then I am just taking the fourth is basically this is the row, and the -2 is basically column. So fourth, how they are taking that, this is the 0 1 2 3 4th, and -2 is basically this is the column position -2 till end. How we can count the -2? Try to understand, guys. -2 basically starts from, in the left hand side we are starting from 0 1 2 3, but when you are just counting from the back, basically that starts from -1. This 3 is basically -1, then 4 is basically -2, 5 is basically -3, so on and so forth. So I am taking the -2. The -2 position is basically the 4, and till end the 4 and 3 is available here, are present here. So that's why they are giving the 4 and 3. This is basically another way of slicing of the array. This 4 comma nothing, that means they are taking this is the row 4th till end, or the 4th row. Which one is the 4th row? The first, in here you can check it, 0 first, second, third, 4th, 5 4 3, 5 4 3. This is the 4th row, and column is -2. How we can count that one? This is -1, -2, -3. So -2 till end. So they are giving the output this 4 and 3. You can check it here. Now we can go to use that again the same line here. Then I am checking the shape. If you run that matrix.shape, if you run that program, basically this area is giving the same output, which I am taking the input here, and after that they are giving the output. Shape is 5,3. The output they are giving the 5,3. What is 5,3? Basically 5 is the row, 1 2 3 4 5, and 3 is the column, 1 2 3. Basically that's why they are giving that 5,3. 5 row is present and 3 column is there. Now matrix.size, in here if you can check that one, basically matrix.size, how they are counting that one, 5 multiply 3, that basically means row multiply by column. So if I run that program, then basically 5 row is there, 1 2 3 4 5, and 3 column is there, and 5 into 3 is equal to 15. So that's why they are giving the output of the 15. Now again I am taking the same matrix here, and I just try to take one position. What is the one position? I just print matrix, this variable, then the 2 comma 1. What is the 2? 2 is basically the row position, 1 is basically the column position. 2 is basically row position, 1 is the column. Which one is the 2 row? This one is the first row. This is the, sorry, this is the 0th row. This is the first row. And this is the second row. In the second row, first position. In the second row, they are selecting here the column position is 1. The 0, this one is the column is 1 column. And this is the position of 9. That's why they are giving the output of 9 here. Firstly, they are checking the row. Then secondly, they are checking the column position. Now again, this is the another way of slicing the array. How we can write down here. In this line, I am using again and again. I am taking the same matrix and same array. You can say like that way. And after that, I already told you that this first position is basically row. This second position is just column. So basically, there is nothing. Nothing means starting from 0 till end. This is the process of writing here. So they are taking the whole row. Whole row means they are taking all the rows 1, 2, 3, 4, 5. Then in the column, they are taking the first column till third column. Third will not be included because last point is always excluded. So they are taking the first and the second column. So in here 1, 2, in 1, 2, 4, 5, 5, 9, 9, 8, 5, 4, they are giving the output here. Sorry, basically they're taking the first and third position. Basically the first position is this 2, 3, so that's why they are giving the 2, 3, then 5, 6, 9, 0, 8, 10, and 4, 3 is the output here. Basically taking the all the rows and the column. What is the criteria? First to second. This is the 0, first, second. So they are taking all this output here. All this output here they are printing here. So this is the another way of writing or slicing the row and column in array. Now in here you can see in this way they are selecting the 2.4, 2:4. Basically 2:4, this is the position of the row and this is basically the position of the column. Just guys remember one thing, the second will be, they are taking the second and the fourth position of the row, and the 0 and 2 means they are taking the column. How they are taking that one? Again I am just taking the same previous array, this array. I am just print here the matrix, so that's why they are giving the output here. Then the position, how they're checking that one? 2:4. That means they are taking the row second position. This is 0, first, second till fourth, third, fourth. Fourth will not be included. So that's why they are selecting this row. Then after that they are taking 0:2. That is the column position. 2 will not be included. It will go 0 to 1. 0 to 1 means the first column, this is the 0th position, this is the second column. So that's why they are giving the output 5, 9 and 9, 8. This is the output. Now I am using the matrix is equal to np.array. I am using the same array, and then again this is another way of writing the same. It's same like the previous program. Guys, please check it by yourself how they are giving the output of the 8 and 10. Matrix.size I already explained in the previous program. Matrix.size basically gives you the row, number of row, multiply number of column. In here you can see the 5 rows are there and 3 columns is there. 5 into 3 is equal to 15. That's why they are giving the output is 15. Now you can see that max function, np.max, how it works. In the matrix, in the array, I am using the matrix. One matrix is equal to, one matrix is the variable name, is equal to np.array. I am using taking this array. In this array, in the max function, whatever the maximum value it will be there in the total array, they are giving the output. See, in this array 1 2 3 5 6 7 5 9 0 9 8 10. 10 is the maximum value. So that's why they are giving the output max value is the 10. In the vice versa, if you are using the mean value, then they are giving the what is the minimum value. In here you can see the 0 is there, the mean value, the 0 will be giving the output for the mean. You can see in this program I am using the np.mean. Basically np.mean is doing nothing. They are just checking what is the minimum value in this program, and here you can see 1 is the minimum value. That's why they are giving the output 1. Then if you want to see in the row wise which one is the minimum value. So what is the way to write down the row wise and the column wise? Basically, axis 0. Axis 0 is basically checking the column. Axis is 0 is basically checking the column, and axis is equal to 1 basically checking the row. Axis 1, guys, don't be confused here. Axis 1, they're checking the row, or axis 0, they're checking the column. So in here I am checking that print np.max. What is the max value in this array? I'm just checking the, I'm taking this matrix here, means whole array, I'm taking it here. Then I'm checking axis is equal to 0. 0 means they're checking that according to the row wise, which one is the maximum value. If I run that program, this is basically this one, this array. Then after that they're checking all the row wise. In first row, 9 is the maximum value, this 9. So they are giving the output here 9. In the second row, again you can check it here, 9 is the maximum value. And in third row, the 10 is the maximum value. That's why they are giving the max 9, 9, 10. This is the final answer. If you check the same thing in the axis 1, I already explained axis 1 is equal to basically they are checking the row wise. They are checking the first row, this is 3, in the second row this is 6, this is 9, this is 20, and this is the fifth. So that's why they are giving the 3, 6, 9, 10, 5. Now we can do the mathematical operation in matrix in axis is equal to 1. Basically they can do the mathematical operations in NumPy through the row wise and the column wise also. If I want to check in this matrix, I am taking here the again same array. Then if I check that one, np.mean function, np.mean basically they are giving the average value in the matrix in the whole array. Axis 1 is equal to basically they are checking the row wise, they are checking the row wise. Then they are just sum it, then they are just average it. How they are doing that? 1 plus 2 is equal to 1 plus 2 is equal to 3 plus 3 is equal to 6. 6 divided by 1 to 3. 6 divided by 3 is equal to 2. That's why they are giving the output here. So in this way they are checking all the rows, they are just sum it all the rows, then just divided it to make out the mean value, and all the mean value, this is the output here. Guys, please check it by yourself. Then matrix is equal to, I am checking this, taking the same matrix, then I am just using dot reshape function. What is doing the dot reshape function? Basically is you can see that 5 is to 3, 5 column is there and 5 rows is there and 3 column is here in this array. And if I want to change this shape, I am using dot reshape 1, 15. That means this array will be going to be changed. 1 row will be there and 15 column will be there. You can see that the whole number, this whole array, they are just make it use it 1 row and they are using 15 column here. Then the same thing, if I want to change it in reshape 4 by 4, if I run the program, then it will throw you error, because in here the 15th input is there. 5 is to 3, 5 row and 3 column is there, the 15th. Then how it can be divided by 4 by 4? 4 by 4 means the size will be the 16th. So it cannot be done. So that's why they are just throwing it, the error, value error, cannot reshape this array of size 15 into reshape 4 by 4. Then I am just taking the same array here. Then I am taking the matrix underscore 1. I am taking another matrix underscore 2. Second array. Basically I am taking matrix underscore 1 array, and within matrix underscore 2, and this is the second array. Then I just print the matrix 1 and matrix 2 here. This is the matrix 1 and this is the matrix 2. Then after that I am just using the add function, np.add. How they are adding that one? Basically that matrix 1 and matrix 2, I am passing matrix 1 and matrix 2. How they are passing the add, how they are doing the mathematical calculation? Please check it here, guys. 1 plus 7 is equal to 8, 2 plus 8 is equal to 10, 3 plus 9 is equal to 12, 6 plus 4 is equal to 10th, 5 plus 5 is equal to 10th. So in this way they are checking all the number, all the matrix 1 number and the matrix 2 number will be added here, then they are giving the output this one. This same thing can be written in different way, matrix 1 plus matrix 2. If you are write down this way, then the same function will be working here. This is another way to write down the sum function. The same thing if I am using np.subtract. np.subtract, if I run that program, basically these are the matrix 1 and the matrix 2. How they are doing that? They are doing the plus or the sum function earlier. Subtract, basically they are doing the minus. They just make it minus from matrix 1, this one matrix 1 to matrix 2. The 1 minus 7 is equal to minus 6, 2 minus 8 is equal to minus 6, 3 minus 9 is equal to minus 6. In this way they just make it subtract. The same thing it can be write down matrix 1 underscore 1 minus matrix underscore 2. Same subtract can be done by writing this way as well. Then matrix multiplication, the same thing it can be done. The matrix 1 and the matrix 2, they will be multiply. 1 into 7 is equal to 7, 2 into 8 is equal to 16, 3 into 9 is equal to 27. Then they will take the second row of the matrix 1, second row of the matrix 2, then the matrix 1 third row and matrix 2 third row. They are multiplying and they are giving the output here. Then guys, I am checking that 2 array, that how I am taking that one. X is equal to np.numpy.array is equal to 1, 2 and 3, 4. 2-dimensional array I am taking in the x variable. Again in the y variable I am taking the another array, np.array within 2D matrix 12, 30. I am taking that one and I just print the x and I am just printing the y. They are giving that same. They are giving this one in the x value, this one in the x value, and 12, 13, this is the y value. They are giving it here, the output. Then I just print the x and y, then they are giving this same value like previously. And then I am using one new function that is called np.concatenate. Basically what they are doing, that concatenate I already discussed about in the my last videos in Python. Concatenate, basically they are doing, they just make it sum from the back side. How they are doing that one from the back side means in all are the integer value in this x and the y, but they are not mathematically sum it. Basically they are taking the matrix 1, 1, 2, 3, 4, then after that 12 and 30 they are adding just back side of that one. So that's why that output comes like that way. In here they are using the 2/3 bracket here in x value and y value again separate, and when we are just using the concatenation function, then in this way you can see that the third bracket is used first, and again when all the things is added up, then at last they are using the third bracket here. Then I am taking that again the same x and y 2 array, then again I am using the concat function x and y dot t. Dot t means transpose. What is the transpose? Basically transpose is just changing the direction. What the directions? Always guys remember the array, they are giving the row, and the column in such a way. But when we are just using dot t or the transpose function, that basically they are changing the directions. All the rows become column like the L shape. All the rows become column. How it can be done? You can see it here 1, 2, 3, 4. 1, 2, 3, 4 and 12, 30. Then this is the right now this is the column. This 2 column is here. This column 1, 3, 12, that will go or that will become a row. You can see it here 1, 2 and 12, it becomes the column, and 3, 4, 30 it gives the row. Axis 1 is basically doing they are checking the column wise. Axis 1 is basically checking the row wise. They are changing it row wise. How it can be done? I am using another program. I'll explain it in the next program as well. Just wait for 2 minutes guys. So I am using the np dot zeros here. I am passing 5. Basically what they're doing, np dot zeros, basically all the zeros will be there and the 5 zeros they will be using. 5 basically that is the column value. So if I just run that one, then in the numpy array they are taking the 5 zeros here. And np dot zeros 6 comma end, there is no end and data type will be the integer. So if I just run that program, in earlier program you can see that all the float value is there. If I am using data type is equal to int, so in that case they are not taking any point value, they're taking all the round value, that is all are zeros. So if I want to change the matrix condition or matrix shape, so in that case I am using the np.0 uh, import numpy as np a is equal to np dot zeros, basically 6 comma 2, basically 6 is the row, 6 or row is there and 2 is basically 2 column is used here. So in such a way I am just using it here. Using it means I am just reshaping the things, I am just reshaping 6 by 2 matrix. If I want to change into 6 by 1, how we can do that one? If I am checking 6 by 1, that means 6 row will be there, 1 column will be there. So if I just run that program, you can see 1, 2, 3, 4, 5, 6. 6 row is there, 1 column is there. Then I am just taking that size is equal to 5. I am just taking the one variable size, that I am using the 5 position or the 5 integer value. Then I am using this 5 or this size variable. How we can do that? I am just taking identity underscore matrix is equal to np dot zeros. I am taking all the zeros. How we can take that zeros? I am just passing size comma size. That means size is equal to 5. This 5 will be passed here. 5 by 5 comma 5, because this size value 5 will become here, data type will be int. So this first position is the row position, second position is the column positions. So if I run that program, then see that 5 row is here, 1 2 3 4 5, and 5 column is there, 1 2 3 4 5. So in this way we can just change the shape as well. And I am using here np.fill underscore diagonal. What is the fill underscore diagonal? How they are reshaping that one? I'm just passing that same variable identity underscore matrix. This variable identity underscore matrix comma 5 comma 5. 5 means that 5 row will be there and 5 column will be there. Then I'm just checking that one, and that I'm just taking this diagonal function, I'm just passing it within the diagonal. Basically they're taking all the zeros. Earlier I'm using in the identity underscore matrix, all the zeros will be there. They're changing in the diagonal way, that the 5, that will be 5. Basically they're making 5 by 5 matrix by 0. Diagonal means in the angle, you can see on the left to right corner, left to right corner, from above to below, from left to right, all the 5s they are using in this array, in this corner. Rest of the all values will be the 0. Then I am using the flatten function. What is the flatten function? Basically you can see that 3 by 3 by 0, sorry, 3 by 3 is matrix is used here. If I do the flatten function, dot a dot flatten function, what they're doing, that they're removing all the rows and column concept. They are all the values, it comes in a straight way, row wise. All the values that will come with row wise. It means if it is like that way, then these all value 127 258 369, all the values it comes in row wise. That is basically done by the flatten function. And guys, I am taking the a is equal to np dot unique. np dot unique function, what they're doing there, in this matrix, in this array, whatever the repeated point will be there, repeated integer value will be there, then they are taking at least one time. So in here if I run that program, then you can see the 0 is used here one time, 1 is used one time, 2 is used 2 times but they are taking 1 time. 3 is used here 2 times, they are taking the 1 time. That basically means unique value is giving the only the single time use. If they are using 3 times, 4 times, 5 times, it doesn't matter, they are taking only 1 time that value. So that's why they are giving only the single time used value here. Then they're checking, I'm using the 3 arrays. 3 values is there, 5 arrays there, 110. This array I am repeated here, and again this array I am repeated here, and 598 is not repeated. So 598 is, it comes as it is, and this repeated array, this one and this one, they are taking 1 time. This one and this one, 110 and 234. And unique is basically just minimize the array size. If there is any repeated value, then they are just subtract and they are just taking at least 1 time. It doesn't matter whether it is 2 times, 3 times, 5 times or 100 times it is used, but it will take at least 1 time. Same thing, I'm just taking the A, and within A all the array value is there, and I just make the printout of the A, so that's why they are giving the output here. Now I just discuss about the np.random.rand. What actually this function is doing here. Guys, rand function is basically, random.rand function is basically in our system or in our Python, they are giving the random value. How they are giving it and how the matrix will be used, they are using within the first bracket 5,2. 5,2 means 5 row will be there and 2 column will be there. In here, if I run that program, then you can see the value is going to be changed, because these all values are going to be changed automatically. And random.rand value, if I am not giving any kind of range, so basically they are just taking the range between 0 starting and 1. So 0 to 1, in between all the number it will become. How many times it will come? In this direction, 5,2. 5 row will be there and 2 column will be there. This is the 5,2. And this is the randint function. Randint function is random.rand function that gives the float value, and random.randint basically gives the integer value. In here I am using here 5,10 size is equal to 15. How it checks? They are giving all the value in between, starting from 5 till end is 10th. So in between all the number will become, how many time it will come? It will give the size of the 15. If I am using the 5, if I run that program, you can see they are taking the 5 times different number, that are using 1, 2, 3, 4, 5. If I am using the 10, they are giving the 10 random value, and this random value comes under 5,10. Anything. If I run the program, then different time the value will be going to be changed, but their value limitation will be the same within 5 to 10. Now I am using a is equal to np.random.randint. They are taking the integer value, and within first yellow color first bracket I am using 200. 200 means basically this is the range from, they are taking all the values from 0 to 200, comma size. Size is basically the this matrix size, the array size. The size is 5,3. What is the 5,3? 5 is basically all the row will be the 5, 1, 2, 3, 4, 5, and 3 column will be there. And if I run the program, you can see all the value it comes from 0 to 200, and this matrix size is basically 5,3. Now here guys, just remember the floor and ceiling concept. What is the floor and the ceiling? In that context, guys, just remember one thing. In our home or in our room, in our flat, in our home, you can see what is the floor? Floor is basically the below value, where we can stand, where our legs stand. And what is the ceiling value? Ceiling is the top of the room. So if you remember this concept in a room, floor is the below value and ceiling is the top value. So in that way you can remember all the things here. So I am using that np.ceil value, CEIL. So in that case, first I am just taking AR is equal to here is within one variable I'm taking different number 0 0.23, 0 0.09, 1.2, 1.24, 9.99, comma 100, 1.01, and within that I'm just taking that np.ceil function. Within this function I'm just passing arr. If I'm passing that one, then basically ceiling value below 1 they are giving all 0.23, they are giving the 1, 0.09 they are giving the 1. Ceil value is basically taking the highest position, so below 1 they are taking the 1, and after that if it is 1.2, 1.24 till 1.99 they are giving the output 2, and after 9, 9.99, that is basically 9, next number is 10th, so they are taking the highest number, that is the 10th, and after that 101.01, whatever 0.01 position, 100 next point is 102, so that's why they are giving the output is 102. So just remember guys, whatever the next number 1 2 3 4 5 6 7 8 9 10, in such a way if you see whatever the number below 1 2 3 4, then the highest number will take that output, and after that after fulfilling 1 1.24, that goes for the next number. So basically they are giving the highest number, that is the 2, and after 9 that is the 10th number, so they are using the point, whatever the point value doesn't matter, so that's why they are taking the 10th value. So in such a way the np.ceil function is working. And what is the np.floor function? Floor function is basically the below number they are giving, that 0.23, 0.09, they are just removing 0.23. That means the extra number will be removing, removing, and they are just giving the below number 0.23. Basically they are taking the 0. 1.2 basically they are just taking the minimum value, that is the 1, they are giving the output here. 9.99 they will just removing that one, the below point, the minimum point, that is 9, that's why they are giving the output here 9. Now we can easily understand what is the difference between floor and ceiling value. And I am taking the another function, that is the np.round. Basically what the round function is doing, round function is basically doing that whatever the number float value is there, they are just removing after this decimal 0.23, 0.09, so they are just removing 0.23, 0.09, and 1.2.2, they will remove that one, and they're just taking the full number. 0 they are taking here, 0 is taking here, 1 is taking here. And if the number, if the after this point, if the number is goes to 50, 9.50, in that case if the 0.50 it comes, then in that case they are taking round up for the next number. 9.50, the next number is 10. 10.51, the next number is 11, so that's why they are round it up here. So below decimal, below 50 number, they are taking that full number. 0.23 is basically taking 0, 0.09 taking the 0. So in that case, whenever it increases or it reaches 0.50 number, then they are just taking after number. After 9 is 10, 10.51, after number is 11. Then in here, I just write down one program here. B is equal to np.array 12, 90, 380, 12, and 211. I am using this array, and I am just writing down one condition within print function. Print np.where. I am just using the one condition, b greater than 12. In that case, basically if I run that program, they are giving where the condition is true, they are giving the position. This 12 is basically the position is 0, 90 is position 1, 382, this 12 is 3, and this one is the 4th position. If I run that program, they are giving the position where the first position is condition true. The first, this is the 0th position, 12 is greater than 12, no, so that's why they are not giving the output here. The first position is used here 90, yeah, b value is 90, 90 is greater than 12, yeah, it's true, so that's why they are giving the position of 1, so on and so forth. That's why that's how they're checking the position and giving the output here. So in that case, if I am using the same thing in a different way, b within third bracket a, that is the array function, if I am using that within a1 variable, if I run that program, that in that case they are taking the same program here, they're taking the same condition here, and they're just checking that this position and this position, first position, second position, and fourth position. Which one is that? 90, 380, and 211. These are the positions. So these are the a value basically, and this a value that comes under b using third bracket a. So this value, it goes inside the A1. If I just print out the A1, so in that case they are not giving the position right now, they are just giving the output. The first position output is the 90, second position is 380, and the fourth position is 211. Now I am just telling you these things in just 2 minutes back, and that np.random.randint, basically they are giving the integer value. The 10th comma means 10 means 0 to 10th, all the random value will come. The size is 10, size is 10 basically they are row wise, that they are taking the 10th number. If I am just increasing that one, is instead of using the 10th, I am increasing 15th. Basically you can see it, the 10th number is there, and if I increase the number is 15, if I run that program, you can count it, this 15 number, the Python is automatic give the 15th output. So this function random.randint function basically gives this mathematical output very quickly. This is the magic of the NumPy, you can say like that way. And np.receive function, what they're doing, that whatever the value you are taking it here, npv, within npv variable I am using this total array. If I am just change the receive, 2,5 is 10th, right? So in that case, suppose I have to change the value here first. I'm just taking the 10 value here, and I just want to change this 10 value into receive by 2,5. 2,5 means 2 row and 5 is column. Why it is throws error in earlier I am just taking the 15th number. 15th number cannot be received in 2 by 5 dimension. The 10 number can be done by that. How it can be calculated? 2 into 5 is equal to 10. So if I run that program, 2 row will be there, 5 column is there. Yeah, see, the 2 row is there and 5 column is there. Now index extracting the element from NumPy array. For indexing, count of row index start from 0 and count of column index also start from 0. So basically row and column, what actually it means, it starts from 0, nothing else, nothing extra things they're telling about that. And if I run that program, np 0, 2, 0 is the row position and 2 is the column position. If you see, this 0 position is a 0 row, this is the row 0, and the 2 is basically the column position, 0, 1, 2. 7 is basically the output. Yeah, 7 is the output. In such a way, you can change the position and you can take the output here. If you run the program, you can see that the first row is this one is the first row, and the second column, this second column is the 0, first, second, 3 is the output. Yeah, you can see 3 is the output. Then slicing NumPy array, extracting the multiple elements from NumPy array. Here the index is excluded. So basically what it means, the starting point is included and the ending point, it will not be included. It is basically excluded. The end point. I am telling you again and again, the starting point it is included and the ending point is the excluded. So if you see that one, if you see 2 by 5 array, if I receive this array here, and after that I am just taking that 0 colon 1, this is basically the row position. Which one is the 0 is included, 1 is the excluded, that is means the 0 row, they are selecting this 0 row. And after that 1 is to 3, that is the column position. The 1 will be included, 3 is excluded. So which one is the 1 position? The 0 column 1 position is the 4, 2 and 3 will not be included. So that's why they are taking that 4th and 7th they are giving the output here. Again, if people can change, you can check in your own system, just write down the program. I already explained this program. Now guys, we can see that mathematical operations, how it can be done by the NumPy. The first, we can see the sum, how we can do the sum function. I am just taking one list here. Then within the one list, I am just taking the value np.array lst. I am just passing lst inside that, and I just print out the npm. Then I am just getting all this array here. Then I am just using the sum function, npm.sum axis is equal to 1. What is the axis 1? I told you that guys, axis 1 is basically row. All row will be there. All row they will be, just make it sum. How they're doing that? If I run that program, you can see 10 plus 20 plus 30, that is the 60, 40, 50 plus 60, 40 plus 60 is 100 plus 50 is 150. In such a way they just make it sum function. If you using the axis is equal to 0, so in that case they will just make it sum in column wise in such a way. 10 plus 40 plus 70 is 10 plus 40 is 50, 50 plus 70 is 50 plus 70 120, 120 plus 100 220. In such a way they are just make it sum here. You can check it here. Then the mean function, what they are doing, that mean is basically giving the average number. How they are giving the average? Basically axis 1. Axis 1 I already told you, that according to the row wise they are make it sum all the things and they will divide it one by one. 10 plus 20 plus 30, 10 plus 20 is equal to 30 plus 30 is equal to 60, 60 divided by 3 is equal to 20. Yeah, you can see the value is 20. In such a way they are just make it all the rows sum first then divided by 3. So basically mean function they are doing that. Axis 1 is basically they are doing that, that is according to the row wise axis 1, and mean function they are just make it average. Axis 0 is nothing. Axis 0 is basically they are taking according to column wise. Now it is very interesting part, you have to learn that one. Replacing element in NumPy array. How we can replace the one number, one value or the two value from the that actually existing array. So I am taking the one existing array inside the lst function, this one. Then I just make a printout. So they are just giving this printout here. Then I am just taking another lst2, that is the lst, and this one is the lst2 np.array lst2. I am just make it print out here this 2. Then what I am doing, that I am just taking the another variable np3 is equal to npm divided by npm by 1. It means this npm1, this npm1, and this is the this is npm and this is the npm1. So all the value will be divided by 1 by 1. 110, the same position, guys. Just remember one thing, that you have to remember the row and the column wise positions. The same position 102 10 is the position is 0 row 0th column, and the npm1 this 110 has a same position. So this 110 will be divided by 110. This 90 0 row 1 column, this 90 will be divided by here. This 0 row second column is again divided by here. So in such a way they're checking all the row one by one and they are just doing the divided one by one, and in such a way they are just giving this division function, and after that they are giving the output here. All the values are the same, all the values are npm and npm1 are the same, so that's why they are giving all the values are the same except one. This is the infinite. This last one they are giving the infinite. Why? Because in the mathematical calculation the npm, the 110 is there, and in here if you are divided by any number, mathematical number divided by 0, then in that case that answer is coming the infinite. That's why they are giving the output here in this 0 1 2 3, the third row and third column position they are giving the infinite. Now considering the array as follows, how we can do that? I am just write down, I am just taking the arrays here. Then in this here they are giving this output. So I want this output should be changed. How it can be changed? I am using np within third bracket first clone. I am using nothing. That means this is the row position. So they are taking from the 0 to till end. All the row they are taking one, and comma. Again, I am not using the starting and the ending point. They are taking all the column positions. So basically they are taking all the row and all the column, all the rows and all the columns, and they want to change it, or I want to change it is equal to 100. So if I run that program, all the values right now, these values changed into 100. If I want to change it in 200, then you can see all the values will be going to be 200. So in your choice, you can guys change all the values in the matrix or in the array. Now I am just taking the np 2 by 2 is equal to 999. So 2 by 2, this is the second row and this is the second column. So basically in this previous array I want to change in the second row position and second column. Which one is the second row position? 0 1 2. This is the second row this one, and in the column position 0 first second, this is the second position. So they are changing that 999. They are changing irrespective of 100. They are changing that 999. So guys, if you are if you want to change this number, so this is the position. You have to write down the position here, row and the column. This is the row is 0, a column is the 0. So if you are using the 0 comma 0, if you want to change it 2000, you can use it 2000. Then you can see this value can be changed. See this 0 and this 0, basically the row and column I write down here, and I want to use suppose 2000. So you can see this point is changed here. So in such a way you can give the position and you can change the number. Now I am taking within a value 1 matrix. This all matrix, all the arrays, they are taking it here. Then I am taking the B, another matrix. I am taking that one. Why I am taking that one? To do the another way of multiplication. I am just print out A and B. So all A, this A and B is already print out here. If I multiply, this is called the matrix multiplication. What is that? How they are doing that one? So it is very again interesting part. Guys, remember in here 2 by 3 matrix format is used here in the A, and B 3 by 2 is used here. 3 is the row and 2 is column here. Then how it will be multiply? So guys, just remember in first position they are taking all the rows, all A values, they are taking the rows in matrix, and the B they are taking the column first in this one. Suppose 1 into 1 is equal to 1, 3 into 0 is equal to 3, into 4 into 5 is equal to 20. So after multiplying it, they are just sum it. So 1 is equal to 1 is equal to 1, 1 plus 3 into 0 is equal to 0, plus 4 into 5 is equal to 20, 20 plus 1 is equal to 21. They are giving the 21. And after that they are taking the second row of the A. Then again they are taking this second column in here. So 4 into 3 is equal to 12, 12 plus 0 into 1 is equal to 0, plus 2 into 2 is equal to 4, 12, 10 plus 2 is equal to 14. So in such a way they are giving the 14 output. So guys, remember, firstly they are taking the row, they are multiplying with the column, and then they are taking this one, then they are multiplying it here. See 1, 3 and 4. Then they are taking this one and multiply it and sum it, and they are getting the output here. In such a way, again this one they are taking and they are multiplying with that one, then sum it, they are giving the output, and after that they are multiplying with this one with that one, then all the values will be sum up, then they are getting the output here. Now guys, in earlier I am not able to explain properly the transpose variable, how it works. Basically transpose of matrix, how it works. A is equal to np dot matrix. If I am taking this one as a matrix, 3 by 3, 3 row and 3 column is there. So in here you can see guys, all the rows, all the columns, this one becomes rows. So 5 4 1, this one 5 4 1, this is basically, this is the column. 3 0 0, this is basically the column. 2 1 1, basically this is the column. It is becoming the row right now. If I just use a dot t, it basically means that transpose. How they're doing that? 5 3 2 5 5 4 1, this is the column. This column it becomes row now. 5 4 1. 3 0 0 column, it becomes row now. 3 0 0. 2 1 1 column, this becomes row now. 2 1 1. Transpose is basically they're changing the position. All the column positions they transfer it as a row. Then I am just taking the another variable. So a is equal to np dot array 100 200 and 23 12, and np dot array 10 20 12 21. I am taking two array here. I am just taking the a and b, all the variable it comes, and how the v dot function it works. np dot v dot is basically doing that, this function, they are taking all the value, the 100 into 10 plus 200 into 20 the same position. In the A position, 0th row, first column, second column, first row, 0th column, and the first column. So 100 into 10, 200 into 20, 23 into 12, and 12 into 21. After multiplying all the values, they are make it sum, and they are giving the output. They are giving the output 5528. How it comes? If you want to know, or if you just do not understand that one, you can just follow that one, this line. This 100 is multiplied with 10 plus 200 multiplied into 20, 23 is multiplied into 12 plus 12 is multiplied with 21. Then again, I'm just taking that sample array 10 to 100 to 210 in here. Then again I am using a reshape 5 by 2, and if I just run that one, you can see that I am using that numpy.arrange 100 till 200, and I just change it in reshape it 5 by 2. They are giving the 5 by 2 in array. How they taking the number? Guys, just remember one thing in here, try to understand. The starting point is 100, and till it will go till 200. How it goes? The 10th is basically the jump value. What is the jump value? The first point will be 100 plus 10, 110 plus 20. So every point they just make it plus 10, 10, 10, 10, 10. In such a way they are just changing it. If you are using the 5, then they just make it the every point the differentiation will be the 5, 5, 5, 5 with each number. And after that, the mathematical operation, what they're doing, that the reshape function 5 by 2, basically they are change it in the 5, all the values, they are change it with 5 rows and 2 columns. They're changing it. Then again you can see they are taking the 100, the starting point, and 200 is the end point, 10 is basically the jump point. So the starting value is 100, then every point they are just plus 10, they are taking the value, and 190 plus 10 is equal to 200. Basically the last 200 point is not included, so that's why they are not taking this number. Now mathematical range function, how it works. If you run that program, you can see it starts from 15 till 56. The first point is included and last point will not be included. The last point always it excluded. So it's the number, all number, if you see that it starts from 15 till 55, it is the end point. And in the you can see it is the string slicing. If I am using the print A, and within the third bracket I am using the first position of the row. First position means 15 is the 0th position, 16 is the first position. So that means they are not taking the 15 number. So that's why they are taking the 16 number. And from the end is basically the 55. From the end they are not taking the last number. So I am using the -1. So if you are doing that one, so the last 55 is not included in this output. You can check it here. Write a NumPy program to convert a given list into an array, then again convert it in a list. How we can do that? So I am just using the input NumPy as np, then I am just taking one array here, and I am using the array, that one, then I just print it here in a list format. How I can transfer it? I just use L1. I am taking the one variable is equal to list, and within list function I am just passing the a. If you are just write down this one, then this array will be going to be changed into list function. If you check that type, then you can see this is the numpy.n dimension array, and if you just check that which kind of array it is, basically this is the list. In this way we can change in data type in list. Now this is last program, guys. I am just taking a is equal to 1 2 3 4 5, then a1 is equal to np.array a. I am just passing a all the values here, and then I just print out a1. And after that I just check b is equal to list a1. I am just passing the same this list. How I am passing that one? This list I am passing in within a1 variable by passing np.array function. I am passing the a. So a1 value is right now 1 2 3 4 5. Then after that I am just passing this all a1 value inside the b. Then b value is right now again 1 2 3 4 5. Then I am checking the one if condition, b double is equal to 1. It means b is all the values is equal to a, whether it is true or not. Then I just write down the print statement. If it is true, then give the print true. If it is false, I am not printing anything. So if I run that program, yeah, 1 2 3 4 5, basically I'm passing it inside the B. So inside B and A, again you can see A 1 2 3 4 5 is already there, so all the values is same, so that's why they are giving the output is true. So if I am checking that one, type A1, that is basically the numpy dot n dimension array. If I am checking that one, basically the list function. So that's it guys about the numpy. I know that this video is quite long, but I believe that one this will really help you to understand how the numpy is, how quickly it can be used in data science field. Basically I hope it will be help you to understand the numpy and to filter the data sets or data set if you are going to be work in the real world in the corporate sector. In case guys, if there is any kind of doubt, please let me know, and please keep feel free to contact with me, and I am always available in 24/7. And thank you so much guys, and please stay tuned with PyData Explorer. Thank you.